Hey guys, today we're going to be talking about 4-2. Ignore the bell in the background as I'm at school right now, but we're going to be talking about transformations on the coordinate plane. So a transformation is basically we're going to be taking a shape, putting it on a graph, and then we're going to move it. We're either going to flip it with a reflection, we're going to translate it, which is a slide, we're going to dilate it, which makes it bigger or smaller, and we're going to rotate it. You have seen reflections and translations last year. Dilations and rotations are newer ones, so we're going to talk more about them. I'm just going to go over them real quick. So image is what you start with. A pre-image is what you start with. An image is what happens after you flip it or change it or whatever. So reflection, imagine this was my y-axis. It's just flipping it. Okay, you're reflecting it. Translation is we're just going to move it. A dilation is we're going to make it bigger or smaller. And a rotate, we're going to rotate it around a point, and that point would be the origin. So here's some more examples. This would be a rotation. This would be a translation. This would be a reflection. And this would be a dilation. Notice how it gets bigger. Now, this table right here, I suggest when you're doing your homework today, you pause the video right here when you're doing it, and you use this table for everything, because this table is going to help you out. And we're going to talk about some easier ways to do these, but for these two in particular, dilation and rotation, this table is going to help out a lot. So a reflection, basically reflect over the x-axis, x, y, x becomes x negative y. We're just going to count the points away it is. So if it's 2 spots away, we're going to move it 2 spots the other way. Translation, there's a formula right there. The easy way to do it is just count. If it says move it 2 up and 3 over, move it up 2 and 3. A dilation, what you're going to do is you're going to take the coordinates they give you and multiply it by a scale factor. And they will tell you what the scale factor is. So imagine the point here was 2, 1. I'm just going to get my pen going real quick for you. So if they said the point here was 2, 1, and they said they want to dilate it by 2, you multiply both of these coordinates by 2. So then it would become 4, 2. Or if they said dilate it by 5, you'd multiply both those coordinates by 5. This is the one that's usually trickier for people. And if we're going to rotate 90 degrees, we're going to flip our coordinates around, meaning if they give us 2, 1, we're going to flip them around so that it becomes 1, 2, and then you add a negative to the first one. And if it was already negative, then you make it positive. For 180 degrees, if they give us a point like 2, 1, we're just going to put negatives in front of them. So it becomes -2, -1. And if it already has a negative, you're going to make it a positive. Okay, so we'll look at a couple examples real quick right here. So this first one wants us to graph this parallelogram. So I'm going to do that real quick. So -4, 3, 1, 3, 0, 1, and -5. So -5, 1. And this is the shape we're dealing with now is right here. And they want us to reflect this over the x-axis. And remember, the x-axis is right here. So they want us to flip it over this line. So to do that, we're just going to count how many points away it is, and then we're going to do the opposite. So right here, it's 1 point. So this was, sorry, I'll label these real quick. A, B, C, D. I'm going to start with A. So if we're flipping it over the x-axis, we're just going to go straight down until we hit that. So it's 1, 2, 3 spots away. So we're going to go 1, 2, 3 spots down like that. And that's our new A. B, we're going to do the same thing. So it's 1, 2, 3 spots away. 1, 2, 3 spots away right there for B. C is 1 spot away. So we're going to go 1 spot this way. D is 1 spot away. So we're going to go 1 spot this way. And just like that, you did a reflection. Now, if it was the y-axis, we would have went the other way. But it's the x-axis, so where you're going to go how far away from the x-axis it is. So like right here, we went 1, 2, 3 spots. So here we went 1, 2, 3 spots. Same thing for A. We were 3 spots away here. 1, 2, 3. 1, 2, 3. Okay, reflection and translation are the easier of the twos. For like translation, I'm going to graph this real quick. So -2, 3, 4, 0, and 2, negative 5. So here's A, here's B, here's C. I'm going to connect those real quick so we know what our shape should look like when we're done. And now it says move it 3 units left and 2 down. So I'm just going to take this dot and go 3 units left, 1, 2, 3, and 2 units down, 1, 2. So here's my new A. And then I'm going to do the same thing with B. 1, 2, 3 spots left, 1, 2 spots down. There's my new B. Same thing with C. 1, 2, 3 spots left, 2 spots down. There's my new C. And you're done. Okay, so translation and reflection are the easier of the two. The trickier ones are going to be dilation, which is what we're going to look at right now. And instead of this being 3/4, I'm going to make it 1/2. Okay, so they're giving us the coordinates negative 4, 1, 1, 1, 2, 3, 4, 4, 7, 0, and negative 3, 1, 2, 3, negative 6. So they're giving us this shape, L, M, N, O. Oh, sorry, let's use P. Okay. So this would be what my shape is going to look like to start with. Now I'm going to dilate this by 1/2, meaning I'm going to take all of these numbers and I'm going to multiply them by 1/2. So I'm just going to write the old coordinates out so we can see what they were before. So this was L, M, N, P. And I'm going to multiply all these coordinates by the scale factor of 1/2. So I'm going to take all these times 1/2. Okay, so that would give me negative 2.5. That's going to give me 0.52. This one's going to give me 3.50. And this one's going to give me negative 1.5, negative 3. And now I'm just going to graph them. So negative 2.5 is like right there. That's my new L. 0.52. There's my new M. 3.50. That's my new N. Negative 1.5, negative 3. And there's my P. And if you look, our shape, our new shape, shrunk. And that's what dilating is. It would have gotten bigger if we would have doubled it. So if we multiply by a fraction, it gets smaller. If we multiply by a whole number, it gets bigger. And the last one we're going to look at is rotating counterclockwise 90 degrees. So I'm just going to move this up a little bit so you can see it. There we go. And then we're going to go down. All right, so a triangle has vertices 1, 5. So we're going to graph this 1, 5, 1, 2, 3, 4, 5. So here's X, 5, 2, 1, 2, 3, 4, 5, 2. Here's Y, and negative 1, 2. Here's Z. So we're going to graph this. Now, I'm going to write out my old points real quick because I'm going to have to mess with these. So I want them to be written down. 5, 2, negative 1, 2. Now, if we look at that table, it says if you're rotating 90 degrees counterclockwise, you flip your numbers. So we're going to flip our numbers, and then you put a negative in front of the first one. So we flip our numbers, and we put a negative in front of the first one. We're going to flip our numbers, and we put a negative in front of the first one. And then you graph those new coordinates. So negative 5, 1, 2, 3, 4, 5, 1. This will be my new X. Negative 2, 5. Here's my new Y. And Z, negative 2, 1. If you notice, what happens is our shape rotated. Okay, so hopefully that's making sense. Hopefully you're understanding it. Thanks for watching the video, guys.